Hello, my name is Chirag Shah, and I want to welcome you to this tutorial on counteracting bias and increasing fairness in search and recommendation system. This tutorial will be presented by Dr. Ruoyuan Gao and myself, and we're going to take turns going through some of the material in this tutorial. So I'm going to get started, introduce the concepts, and then have Royan take over for the main part of it, which is different kind of background techniques and also case studies. And then I'll come back at the end to try to wrap this up. Now, this tutorial does not require any strong background in this area, but it is expected that if you're watching this, you at least have some understanding of how search and recommendation systems work. Also, in this tutorial, we're going to talk about one or the other, but not always the same, or not always both at the same time. But it's understood that whatever we are talking about applies to not just search, but also recommendation systems and vice versa. Because many of the things that we experience in real life, uh, there are these aspects of search systems and aspects of recommendation systems are pretty much blended. So almost everything that we are going to do here will be applicable to both of those, irrespective of what your angle is, where you're coming from. So don't get too concerned about, oh, but this is just all about the search, but how do I apply to recommendation systems? Just know that these are the same issues, these are the same things that you can take away for both of those. So here are our main objectives in this tutorial. We're going to first explore the concepts of fairness. And when we get to fairness, before we get to fairness, we realize that there are things that are very much connected to fairness, and those things include, especially things like bias, novelty, and diversity. So we're also going to touch upon those concepts. Once we know those concepts, then we'll go and see how we can implement these concepts. And while we're doing that implementation, what are those frameworks? What are the ways people do that? How do they measure? So, what are those metrics? And then we'll come to this point where we'll see that there are these traditional metrics that are optimized or that are implemented for optimizing utility measures, such as relevance, user satisfaction. And then there are these fairness measures, and often they are in competition or in some kind of balance. So we'll also talk about ways to find a better balance, find what is a trade-off, understanding and addressing that. We'll see some case studies that give us an idea of different strategies we can apply for addressing bias and promoting fairness. And then finally, we're going to wrap this up by listing challenges and opportunities in this area. Right. So we're going to go through from the concepts, the basic ideas, to taking examples, case studies, showing how different frameworks work, how do we do the different analysis, and then getting to the place where, okay, well, where do we go next? Right, so that's sort of the idea here. So again, we are Royan Gao, who received her PhD in computer science from Rutgers University, and myself, I'm an associate professor at the University of Washington. And here's our overview for this tutorial. So we're going to start by first just thinking about some examples where we see cases of bias or unfairness. We'll introduce the idea of bias. We'll see different kinds of bias, and then we'll jump to fairness in search and recommendation systems, and then couch fairness as an optimization problem as a way to show how we can quantify it, how we can optimize it in different situations, right? And then challenges and opportunities, and wrap up. So here are some examples. And if you've ever done anything in this field, if you've ever read anything or attended any tutorial, chances are you've come across these, because these are kind of famous examples at this point. One of them is this example of searching for CEOs. And if you go search for CEOs in image search, and again, this may not be the case right now because this is a couple of years old, that you see examples, or you see results that are mostly men, mostly white men. right? And so this is kind of a case where why are these things so biased? Now, it happens to be the case that most of the CEOs in the Fortune 500 companies are male, most of them are white, right? But uh, this kind of sends a wrong message that this is the image of a CEO, that CEOs are white men. And so this bias is coming from the data that we have. So again, the data shows that most CEOs in those top companies are male and white, right? So this is an example of bias coming from data. Here's another example, and this is a very different kind of example. And again, this is probably not going to be how you see things now because, again, it's a couple of years old and things have been changed or fixed. But there was time where you search in YouTube for NASA and you see some of the top results are really some sensational stories. And actually, most of them, or almost all of them, are just fake stories or clickbaits, not real things related to NASA, right? And these are the things you see, but why? So it happened over some period of time where these are sensational news stories, sensational videos. As you can see, these are very attractive, right? And so as people are searching for other things, they find this somewhere. And even though they were not looking for this seems um, very attractive. It seems like, I'm curious, what's that about? So they click on it, and the search engine takes this as a signal that this is the right thing, this is the positive thing, right? So the user searched for this, they clicked on it, so there is this positive association. And so the way the algorithms are designed, they take this as a positive signal, and then they start promoting these videos even more because they're optimized for increasing this click throughs, increasing this engagement, right? Increasing the spread, increasing the shares. And so the way the algorithms are designed, and again, I'm not suggesting that some algorithm is specifically designed to do this, but the way the algorithms are designed, it gives it gives this advantage to this kind of clickbaits or stories that seem very attractive on the surface but lacks a substance. So you click on it and you get basically thrown into some kind of conspiracy theories, some kind of fake news and things like that. But that's what gets the clicks. So the algorithm inherently kind of learns that these are the right things to show, right? And so this is an example of algorithmic bias. And then there are other ways to have algorithmic bias, but this is one. And we see this in many other ways. So this is actually, again, a famous book at this point, where as the very the picture, the title picture of the book shows, you start searching something like why black women. So in Google, you start seeing these suggestions that are mostly negative, right? And so again, in this case, also the search engine has learned this associations based on what's out there, based on what people are clicking on. So it's a complex combination of what's in the data, what gets popular, what gets spread, and that it finds as relevant. And so these are the suggestions that it starts giving. Now, again, if you right now search on Google, you may not see exactly the same things, right? Because things have been changed, fixed. But this is a known problem. We've known this for a long time now, right? So again, it's a issue with algorithms. But this also comes up in other ways. So sure, there's problem in data, there's problem in algorithm, but look what people are doing. So here's a chart from Facebook engagement in the US 2016 elections. So you can see on the x-axis you have months from February going to the election day, which is in November. And you can see, and what you're seeing here is the top 20 stories that were labeled to see if they were actually mainstream news, real news, or fake news. And you can see the amount of engagement going down on mainstream news as we approach the elections, and fake news going up, right? And so again, the result of whether there's data bias, there's algorithmic bias, but the result is what it does to us. And here I should mention that this is not all the fault of the system. This is not all just the data and the algorithm. Right? It's also us. We like seeing sensational stories. We tend to click on those things. We tend to share those things a lot more. And because we do those things, the algorithms learn that that's the right thing, that that's actually good, that those stories are getting attention, they should be surfaced even more. And so they keep promoting those even more. And because they show up higher in our recommendation lists or in our feed, we tend to click on those things even more. So this kind of creates this bias loop. This creates this kind of feedback cycle, right? So it's not just the system. It's not just the people, but there's this complex interaction happening. More recently, we've seen misleading stories about COVID-19 illness taking over a lot more attention than actual legitimate source stories coming from legitimate sources, right? To the point where it's like hundreds of times more attention and engagement than the actual stories news coming out from Center for Disease and Control in the U.S. or the World Health Organization. Right? So these are the authoritative bodies, and they disseminate news, and there are many others, other local, national, international organizations. But we like to get those stories that are sensational, that catch attention, and those are the things that have higher engagement, and that higher engagement leads to those being ranked even higher, and that higher rank leads to higher engagement, and so on. So why is this problematic? Obviously, there are things that we've already seen that it's a bad idea. So those stories about fake cures for COVID-19, or misleading suggestions about products that will cure coronavirus, that could actually cause real harm to people. And we've already seen many cases of people suffering because of buying into those stories. But overall, in general, these kind of things create unfair distribution of opportunities and resources. Right? So how does this happen? And here's a case of search engine. So what we see here on the right is click-through rates on the top 10 results in a search engine. So not surprisingly, the first result gets clicked a lot, but then it dramatically drops to the second, third, and by the time you get to the 10th result, it's barely 1%. And most people are not even going to the second page, third page. They would run a new query, they would try a different thing, but they repeat this pattern. And what it means is if something comes up at the top, people are more likely to click. And because the way the search engines are designed, those things get counted towards the relevance or popularity of that story. And so we kind of keep going through this cycle. But think about what happens to those other things at the bottom. What happens to those on the second page, third page, right? They just never get the light of the day, right? So they don't get shown, and because they're not being shown, or people are not making it to that bottom rank or the next page, they don't get the clicks, right? And that makes it difficult for them to have their word out. So on one hand, we can say, well, we got tons of information, we got billions of web pages, we got Wikipedia, we got all kinds of things out. We live in this information age, but that's of no good use if most of that never surfaces. So the only thing that we see are barely the scratch on the surface from this whole sea of information, right? And so this has implications for equity, right? This has implications for opportunities for all those other things, right? And so the way our algorithms are designed, the way we perceive these things at the top rank, so there is also this cognitive effect, right? Where we believe that things that show up in the higher ranks are more relevant, they are better, they're high quality, right? And so our own thinking adds to this prejudice that's already existing, right? And so this is kind of problematic for both sides: people who are generating and providing information, and there are people who are actually making their living off of this, and people who are consuming information or using information. So this has actually far more severe implications than just a few bad stories about elections or pandemic. We should care about this. Why? Well, of course, it's the right thing to do. This is not good. It's not good that people consume wrong information, bad information. It's not good that the opportunities and resources are not so skewed in terms of their distributions. Um, but this could also create big problems. And again, we've already seen this in the case of pandemic and the health situation. We've seen it in political situations and elections and so on. But this is the same behavior. This is the same idea that spreads in all kinds of areas. So there are these things lead to bad decisions. That's bad. But if we actually address this, if we care about this, this is not just doing the right thing or doing the moral thing, but it actually can lead to better business. It could lead to a more sustainable service or platform. And so, one of the things that I discovered personally was at Spotify, where I was visiting research scientists some time ago, that uh, there are lots and lots of artists, right? But everybody wants to listen. If everybody wants to only listen to the popular artists, then think about all those 95% of the artists that never see their music kind of listen to. They never see any revenue coming from that. And so that's not good for them. And maybe it's also not good for the users who only get to experience a very narrow sliver of the music landscape. So it's good for a service like Spotify to address this skewness, this bias, and make it more fair so that the users can be happier in the longer term, that they get to experience more kinds of music, and the artists can be happier because more artists get exposure to this large user base. Right? This could also be great for profitability of your company. So again, and without sharing any more details, I can say, as an Amazon scholar, I worked on some problems where it was important to bring out some diversity in product recommendations. Why? Because again, it's a similar idea. If the same kind of product from a very small number of vendors are being promoted and being purchased, but then what happens to all of those other vendors and their products? Right. So it's not good for them. And then, of course, think about the choices for your users, your customers. Right. And so often people rely on these recommendations to not just find the most relevant things, but also suggestions for related things, suggestion for the things that they're not even thinking about. So there are cases where people don't know exactly what to ask for. There is no clear sense of relevance, and yet they're looking for suggestions. They're looking for recommendations. So being able to give them diverse recommendations, being able to take them a little bit outside of the comfort zone is actually can be good for the customers as well as for the company. So now I'm going to hand it over to Ruoyuan to take us from the beginning of some of these ideas. What is bias and how do we connect that to fairness and so on?
What is bias? Bias has been discussed for a long time. Back in 1996, bias in computer systems was proposed as systematically and unfairly discriminate against certain individuals or groups of individuals in favor of others. Algorithms that learn from and mirror the data may carry the bias to the web and interact and affect users' cognition. In search and recommender systems, bias is usually considered from the exposure perspective. For instance, how much attention the items are receiving, how many items are shown to the user. Bias is everywhere. It's not just present in a single component of the search and recommender systems. There is data bias, there's algorithmic bias, and cognition bias or activity bias. All of those biases are closely connected to each other and reinforce each other, forming a vicious cycle. For instance, a female user may be looking for a job, and a biased as recommender system may, based on the gender information, recommend a very low income job. What's more interesting here is although the system is biased, the user may actually be interested in this job and click on the job. And thus, this gives the system a feedback that the recommendation is good, it's relevant, it's effective, which as a result reinforces the bias in the system. So there are many causes to the data bias. First of all, humans are biased. The data we generate or the data we produce naturally reflects our cognitive and activity bias. Secondly, different groups have different sizes. For instance, we have minority population in the demographics. We have in the recommender systems long-tail items, long-tail users. Bias may also arise because of the difference of cultural and educational background and due to complex historical and political reasons. Finally, if we are not careful, the approach we collect data or sample from data may also yield bias. Okay, if the data is biased, then it is very possible that the algorithms we use to learn from the mirrored data will carry the bias to the learned models. For instance, a naive algorithm will tend to optimize the performance for the majority, which as a result will exaggerate the bias. Bias can also happen during the feature encoding, feature selection, whether the feature is directly associated or indirectly associated with sensitive attributes. In this case, we may want to use some causal analysis to decouple the bias from the sensitive attributes. Of course, in the training and evaluation stage, we could also encounter bias. There is also bias when presenting the results and collecting responses from the users. So first of all, what results should we show? A scenario in a very common scenario or training popular scenario here is in the voice assistant. When we ask the voice assistant one question, can you recommend me a restaurant? If the system should only recommend one restaurant to the user, which one should it recommend to us? The second question is how to present the results. For instance, the system is trying to recommend a list of movies. So in what order should these movies be organized? Apparently, that the movie that is provided or presented at the highest position or the most obvious position on the web page will attract more attention. And the third question is what users should we target? Here, an example would be that in the music recommendation, it probably doesn't matter whether we are recommending the same song to a male audience or female audience. But in the case of clothes recommendation, it's probably better strategy to recommend women clothes designers clothes to the female users. Okay. Here are more examples of bias. Gender, race, which are all related to the demographic background. There's item popularity, so whether the item is actively involved with the user activities, whether it's a highly purchased one or training items. And there's user feedback bias. So for instance, a lot of people are commenting on single items, but for the other item, the users are not providing enough feedback. Or In the user case, quite a few users are not involved in the feedback, but a very few active users are providing lots of comments. Opinion polarity. So there are often two sides of the same topic, and there are two sides of the opinions. So how do we present the opinions may also yield bias. For instance, regarding the topic coffee, whether it's good for our health, then there may be benefits associated with coffee, and there may also be harms associated with coffee. So in this case, if we're presenting all the results in terms of benefits of coffee, then we are definitely biased towards the benefits polarity. There's also topical diversity bias, where we are presenting the results mostly from one subtopic or aspect regarding the topic. It's kind of similar to the opinion polarity. So now that we have an idea of what is bias, where bias may exist, and what causes the bias, now let's talk about what is fair. A lot of people are often, including myself, are confused between the concepts of bias, fairness, and two important concepts, diversity and novelty. So we had a lot of discussions regarding this topic, and here we're presenting our own understanding of the difference and associations between those four concepts. So first of all, bias. We view bias as the skewed exposure regarding certain attributes. For instance, in the image search, where the query is a CEO, the top results are all male white CEOs. This can be considered as skewed exposure and biased against the female CEOs. Diversity is concerning the exposure of different aspects. So one topic may have different subtopics, or it may be associated with ambiguities. So the goal of diversity is to improve the coverage of the different aspects. Back to the CEO example, we want the CEO images to be of different genders, races, and occupations. Novelty addresses the redundancy in the search results in an effort to reduce the user's effort to access novel information. So we want the images to have very distinct characteristics, for instance, composition and sources. So the user doesn't have to go through a whole list of images just to find a novel one. Okay, different from bias, diversity, and novelty, here we have the fairness, which is more of a subjective overview of the system. So fairness is a subjective moderation on how we should present the results. Search results can be presented according to different fairness definitions. Because we have different definitions of fairness, so fairness is really a subjective matter. In terms of the relationships between bias, diversity, novelty, and fairness, we think of fairness as one way to counteract bias. And we think of, and actually it has been shown that diversity and novelty can help improve fairness, and fairness can also help to boost diversity and novelty, but they are not necessarily the same because the goals are different. Okay? So when we talk about fairness definitions, we are usually talking from two perspectives. One is individual fairness, the other is group fairness. Individual fairness requires that we treat similar individuals similarly. For instance, given two identical credit history, we want to make the same loan decision regardless of the applicant's gender or race background. Group fairness requires that each salient group of people should be treated comparably. This happens in mostly, for instance, in the hiring or college admission. We want to include as many or as diverse as possible to build a more diverse culture. It also happens in the recommendation setting where we're not only providing the service to active users, but we also want to make sure that the inactive users, which is usually the long tail or the majority, so that they are happy with our service. Group fairness and individual fairness are different, but they are somehow connected. So first of all, group fairness does not guarantee individual fairness or vice versa. Individual fairness under certain circumstances can promote group fairness. So for instance, if we have the individual definition where we want all the individuals, where we want two individuals, one should never be ranked higher if they have the same ranks qualification score or utility score. And we have the similar definition for the group fairness where one group should never be ranked higher than the other if they have the same expected utility. Then in this case, for some data, the individual fairness can actually guarantee the group fairness. So to see when individual fairness and group fairness are different, here is an example in the resume search. So we have 6 candidates or applicants with different qualification scores. If we are to rank the candidates based on the descending order of their qualification scores, then we have the list as shown here. So obviously, if we're requiring that individuals with higher qualification scores are ranked higher, and this is fair to every individual. But when we look at the results, we observe that all the female candidates are ranked lower than the male candidates. So this is apparently unfair for the female group because this group receives lower exposure compared to the male group. So how do we improve the group fairness in this case? We can re-rank the list by promoting the position of C4 and C5. As we can see on the second rank list here on the right, at rank position 2, rank 4, and rank 6, we're always ensuring that there are 50% male candidates and 50% female candidates. This can be considered fair for a female group. But apparently this is unfair for the individual C2 and individual C3 because we're comparing C4 and C2. C2 apparently has a higher qualification score, but he receives a lower rank or exposure compared to C4. And the same goes for C3. Okay, now let's talk more details about the fairness definitions. So first of all, we have the very commonly used notion statistical parity, where the demographics of those receiving positive or negative classifications should be treated the same as the demographics of the population as a whole. More formally, decision D should be statistically independent of the sensitive attribute A. So back to the loan example, if we decide to give the loan to an individual with this credit history, then this decision should be made regardless of whether this applicant is a male or female. We also have the definition regarding the original labels or outcomes, original labels of the data. For instance, if we're making the prediction as 1 while the original label is 0, then this decision should be the same for all attributes. So when we talk about group fairness, there are 3 types of definitions. The first one, demographic parity, which addresses the items of different groups to receive similar treatment. In this case, we want to make exposure according to the group size proportion. For instance, if there are in fact 80% male CEOs and 20% female CEOs, then we want the result to reflect that there are 80 versus 20. The disparate treatment definition, on the other hand, requires that the items receive different treatment. So in this case, think about one group has a lower overall relevance compared to the other, or the average relevance are lower than the other. Then we want to make recommendations based on the relevance. So in this case, the exposure should be based on the average or overall group utility. Finally, disparate impact. This stresses items of different groups to receive different outcomes instead of treatment. So think about the items are going to receive attention from the users, such as the click-through rates. Then we want the exposure to be based on the expected group attention that is going to be received. This is considered as the outcomes. So we can see that demographic parity, disparate treatment, disparate impact are all addressing different kinds of fairness issues, and they should be used according to different application scenarios and the design need. And apparently, most of the time, they are not able to be achieved at the same time. If you're interested in the fairness definitions, here are some suggested readings. Okay. All right. Now that we have a basic understanding of the concept of bias, the concept of fairness, let's talk about how to counteract bias and achieve fairness. What is bias and fairness? Let's talk about how to counteract the bias and achieve fairness. Fairness strategies are usually divided into 3 categories. The first one is happening during the data space, where we call it pre-processing technologies, pre-processing strategies. This happens before we're actually training the model. And the second category is the in-processing strategy, which is when we learn the model, when we have the algorithm training during the training phase of the algorithm, we're doing some processing to reduce the bias. And finally, the post-processing is that after the model has been learned, before we're presenting the results, we're delivering the results, we want to do some processing to remove the bias and further enhance the fairness. So more specifically, the pre-processing removes the bias in data. This can be done by either proper sampling from the data to improve the coverage of all different kinds of groups. We can also try to balance the data to increase the coverage of minority groups. And finally, we can try to repair the data. So we have to ensure that the labels of the data are correct, and we also may remove the disparate impact that has been existing in the data. So in-processing usually involves encoding the fairness as part of the objective function, and this is typically done or implemented as a regularizer. So essentially, we're encoding fairness constraints as something that punishes the performance of the algorithm, so that if there's low unfairness, then we're giving more punishment. So the fairer the results, the better performance or scores the algorithm should produce. The post-processing, the most popular approach for post-processing is re-ranking to improve the fairness. This could involve, for instance, the greedy approach, the constraint maximization problem, where we have a set of fairness constraints and we try to maximize the utility. And we could also formulate this as a multi-armed bandit problem. Of course, we should never forget the utility of the system, because that's how we're going to make the system useful to the users. So fairness-aware systems should be evaluated on both utility and fairness. Utility, system utility or user utility measures how well the system assists the users in information access. Fairness moderates the exposure of the information so that different information and resources get fair chance to receive user attentions. Here are some examples of the commonly used utility metrics. There are decision support and accuracy-based measures, for instance, mean average error, precision, recall, F1, and hit rate. There are also rank-biased metrics, such as mean reciprocal rank, normalized discounted cumulative gain. There are also diversity, novelty, and intent-aware metrics, such as alpha NDCG, novelty, and rank-biased precision. The intent-aware version of the expected reciprocal rank and NDCG. So fairness metrics have been proposed from the perspective of the distribution and proportion. For instance, we can use the KL divergence or entropy-based measures to measure how biased the results are, just as a measure for the fairness on the other hand. We could also measure the mean skew and max skew, which also measures the degree of bias, and on the other hand, reflects the fairness. So there's also fairness metrics proposed based on the error, the prediction error, or pairwise comparisons. And there are also metrics developed for the probabilistic models compared to the static models. Okay. So now that we know there are two important factors, utility and fairness in the fairness-aware systems, we can consider fairness as an optimization problem. So we need to balance between the two, and we want to improve the system performance at the same time. Okay. So there are three types of optimization policies. The first type naturally comes to us is that usually, for instance, the government wants to enforce some fairness constraints. So in this case, we are given the fairness constraints, and our goal is to maximize the utility while satisfying the constraints. For instance, we want to make sure that there are half male CEOs and there are half female CEOs in the image results, but our goal is still trying to maximize the retrieval precision. And the second type of policy is given sometimes we want to make sure that the system has a minimum utility of some threshold. Say we're given the minimum recall to be 0.7, and then our goal is to maximize the fairness while ensuring that we meet the minimum utility constraint. Okay. Naturally, the third type of optimization policy is joint optimization, where usually we are given the trade-off or we are learning about the trade-offs between fairness and utility, and our goal is to maximize the utility and fairness based on the trade-off. So for instance, the simplest and straightforward approach is to do a linear combination of the two factors with different weights. Well, but here, there's a very important challenge or question here. Is there a trade-off? Right? If there's not a trade-off, then why would we want to maximize based on the trade-off? And the second question to ask is, if there's a trade-off, how do we decide the trade-off? Who decides that? In practice, people are usually deciding the trade-offs based on tuning the weights or finding the Pareto optimal by looking at the problem as a multi-objective optimization problem, or just to see what trade-off makes the system perform better in terms of their own concern, utility, or fairness metrics. Okay. More on the trade-off. In theory, results with optimal utility may also have optimal fairness. And of course, there may also exist the trade-offs. But whether there are trade-offs or what the trade-offs are depend on the data and the algorithm. In practice, it has been shown that optimizing utility alone leads to high unfairness, which is the typical algorithmic bias we're talking about. It has been shown that through many experiments that introducing fairness into the system usually leads to lower system utility. So which one is more important, utility or fairness, is more important really depends on the application scenario and needs careful attention. Okay, having covered the concepts of bias and fairness, the strategies for counteracting bias and fairness, and the evaluation in terms of utility and fairness, let's put all these pieces together. So when we are approaching a problem with fairness concerns, how do we approach it? Here we present the following analysis framework. Let's start with data. Before we're doing any system building, we need to understand the characteristics of the data. In fact, we can derive from the data the solution space, which tells us the possible outcomes given the fairness constraints and the utility functions. This will help us to analyze the trade-offs between the utilities and help us to make decisions about which optimization policy should we use. Should we jointly optimize for both utility and fairness? Should we simply have a fairness constraint and then maximize for utility? Well, once the policy has been decided, we can go into designing and implementing the specific algorithm, and then put this algorithm through evaluation based on utility and fairness, which in turn will help us to improve the performance of the algorithm or the model. Alright, so how do we start with data? We know that algorithm performance depends on data. In this plot here, we can see that we have a solution space and we can actually tell what is the maximum fairness and what is the maximum utility from this solution space. We could also tell that the Pareto optimal surface gives us a good trade-offs between the two. So the challenge here is that can we estimate the solution space given a data set? The answer is yes. So given utility and fairness functions, the first step is to do proper sampling from the data to make sure that we are not biased during the process of sampling. And then from the samples of the data, we can estimate the domains of the variables in the utility and fairness functions, and then further estimate the range of the functions. By using the framework proposed by us in 2019, we are actually able to derive the lower bounds and upper bounds of the fairness and utility dimension on datasets. So here is an example. On synthetic dataset, this is a density plot of 10K random samples of the solution set. We are sampling 30 data points out of 100 data points. As we can see on the left plot, when we're trying to improve the relevance, we're observing a decrease in the fairness. While on the right plot, for a different data set, when we're trying to improve the relevance, we're also improving the fairness. Or in other words, fairness helps us to improve relevance at the same time. So this makes sense that when we're deciding the optimization policies, we have to be careful. Okay? So with the optimization policy as a guidance, we can then design and implement our own algorithms. Here, for example, in a Google search dataset we collected in our 2020 paper toward creating a fairer ranking in search engine results, in this dataset, we collected top 100 results for each of the 100 queries, and then for each query, we're clustering the results into different subtopical groups. So we developed the epsilon greedy-based algorithm, which explored the results with epsilon probability, which represents the randomization here, and exploit which improves the fairness with probability 1 minus epsilon. So in other words, with probability epsilon, we randomly select a subtopic group, and then we pick the top one in that subtopic. With probability 1 minus epsilon, we pick the fair subtopic and then pick the top one in that subtopic. So a special case is that with probability epsilon, we're always making sure that we're picking the fair subtopic. So the lower epsilon, the higher fairness would be expected. The results on Google search dataset shows that here the degree of bias represents the fairness on the contrary. So we can see that our epsilon greedy based algorithms are able to significantly decrease the degree of bias or improve the fairness. In terms of the relevance metric NDCG here, we do see there is a decrease in the performance, but statistically this is not significant. So on the diversity and novelty based metric alpha NDCG score here, we see an increase in the score. On a different dataset, the New York Times corpus dataset, because we don't have a reference ranking, we use the BM25 as the baseline ranking. We can see that our algorithms are able to improve the fairness, improve the relevance, and also improve the diversity and novelty at the same time. So this implies that with a good fairness-aware strategy, we are able to improve fairness without sacrificing utility. In fact, what's better is a good strategy can help us improve fairness and improve utility at the same time. Okay, now that we have talked about what is fairness, how to achieve fairness, the next question is, who should we bring the fairness to? In practice, there may be more than one stakeholders that we need to address the fairness. For instance, in a marketplace where we have multiple stakeholders. Here's an example. As a content provider such as Spotify or Netflix, we have two basic stakeholders, the content supplier and the consumers. So the content suppliers are trying to sell their content and make sure that their content is exposed to the user. And the consumers are using the service of the content provider to access the content. So if we're always recommending the popular items from the content suppliers, then the consumers are happy, but we're biased against those unpopular content suppliers, right? But if we're only focused on improving the fairness of the content supplier, we may be recommending too much unpopular, irrelevant items to the consumer, which makes the consumer unhappy. So on the other hand, for the consumer side, we have to make sure that we're making the fair recommendations for the user experience in using the service. Okay, so for consumer fairness, it has been shown that users of different age and gender groups, for instance, have different use experience in the search engine results, or have a different satisfaction with the search engine results. So a fair user experience, what should it include? It should include the fair quality of service, which means the users of different groups should be equally or fairly satisfied with the recommended items. And this also includes the cost of service. So this means that the cost for different groups of users should be fair regardless of the sensitive attributes. So say if a rich person should not be paying more than the per person in terms of using the service, unless there are more service provided with extra charge. So in terms of content supplier fairness, we need to ensure that there's fair supplier opportunity. So what does opportunity mean? Is that we should ensure the fair content visibility, whether it's popular or unpopular. we should make sure that they all have the chance to be exposed to the users. And on the other hand, and at the same time, we want to make sure that the content, when exposed to the users, they're receiving a fair chance of the user attention. So the first one is more about the treatment, the second one is more about the outcomes. And then finally, the cost of service again. So different content suppliers should be treated fairly in terms of paying for using the content provide platform. Okay. Beyond those fairness issues that we have mentioned before, there are many practical issues that we must consider. Here are some examples. The terminologies, the frameworks, and conceptual underpinnings. So how do we frame this as a fairness problem? How do we make sure the definitions we're using are correct and are the right thing to do? And how do we conceptualize from the practical, the real world problem to an abstract model and develop the tools and algorithms to address the bias issues and improve fairness? So there are really the matters, these are in experimental setups, the availability, collection of data sets, and the appropriate choice of evaluation metrics. And finally, there's the integration issue. How do we integrate the developed model into the system, into the current system, without negatively affecting the user experience or the profit of the platform? And how do we improve the system through iteration or observe the impact of the fairness-aware strategies with consideration of the user feedbacks into the loop? Okay. As final part of the tutorial, we also want to talk about the challenges and opportunities in the fairness area. Professor Shah will lead this part.
So now we'll talk about some of the challenges and opportunities in this area. As we saw in this tutorial, there are a lot of definitional issues here. So often one of the first questions that comes that you need to address in any application is, well, which definition of bias or fairness you're going to use, especially the definition of fairness, because bias, diversity, those kind of things you can even objectively define. But what is fair is often dependent on what the current social construct is. And so, again, that becomes a big challenge. Then, of course, how do you implement it? What is a good way to do this? So, it's one thing to agree on what's fair, it's another thing to then operationalize it. And then you also discover that there are it's not one size that fits all. So depending on your application, depending on your scenario, you may have to decide which kind of formulation for fairness is correct or appropriate for that or not, right? So simply speaking, if you have statistical parity, disparate impact, disparate treatment, those three common ways to look at fairness, well, which one of those will apply in which situation? So that's actually challenging. We also haven't talked much about the user experience, which is another big issue. So it's one thing to just have an algorithm, define something, and even implement it in a system, but what does it do to the user? Right? Do the users actually look for fairness? How much? How much they're willing to accept or compromise? And so, to study some of these things, and this will be a very quick plug, we recently designed this, actually, not recently, but it's been going on for a while, a game called Google or Not, where we present two set of results for the same query. One of them is directly from Google, the other one has some amount of diversity, right? And so, this is using one of the algorithms for bringing fairness or bringing diversity. And then we ask the user if they can tell the difference, if they can pick one out that they like. And we find that in many cases, they don't, right? So we implemented epsilon greedy algorithm, where epsilon indicates the amount of exploration we want to do, and 1 minus epsilon is that much exploitation we want to do. So when we have epsilon being zero point 0.3, which means 70% of what you see is what comes from Google directly in that rank order, but then 30% comes through some exploration. People can't tell difference. And so that's kind of a good sign because we're able to bring some diversity without affecting user perception, satisfaction. But of course, if you push this too far, so we found if epsilon was zero point 0.9, which means only 1 out of 10 results are coming directly as where they were in the rank list, and the other 9 are coming from all over the place in the top 100 results. They're not coming from all over the place on the web. They're still coming from the top 100, but people they don't like that, right? So again, there is a boundary somewhere, and we don't know exactly where it is. So in these experiments, we found zero point 0.3 is good enough. That's fine, and we don't want to go beyond zero point 0.5. But for different applications, it could be something different. So we have to consider that user experience, how much fairness we want to provide, how much diversity we want to provide. We also have to understand that users, when they are looking at something, when they're clicking on something, well, they're doing it in the bigger context of task, right? And so it's not enough to simply look at a query or a question or their visit to an item page one at a time, but also trying to understand the bigger uh, context of task. Nobody's going to be happy if our efforts to bring fairness inhibits their ability to do tasks. Right? There's also the other issue of how much transparent you want to be to the users. Now, this is a huge issue right now, amount of transparency. So in recommendation systems, it's many of these systems are black box, and so either people don't trust those things, or there are this hidden agenda that can be carried out in this black boxes, and in the long run, that's not a good idea. But it's not clear how much transparency is good or sufficient for the users. We also have to think about making the users aware and educated, right? And so these are some of the challenges, some of the issues. I don't have answers to those because these are still open problems. You can think about fairness in dynamic versus static also. So it's one thing to kind of think about, okay, well, here's a query or here's an action, and here are the recommendation or the search results. But is that a one way to do that? Is that the same way to do that for the subsequent interaction and so on? Or are we going to consider some kind of user feedback in this? Right? So do we do this in a static way, or do we keep doing this dynamically in terms of the notion of the fairness? Right? And how we want to do this. So there is a short term or the immediate term fairness, which one could say, well, that's essentially reducing bias. But what is the downstream effect of that? And so we also have to think about long term. So there are times when you're willing to compromise some utility uh, in the hope that this would translate to longer term fairness. And there are times when, even though something is less fair in the moment, it's you go with that because it allows you to have that longer term fairness objectives to meet. So again, the balancing that also is a big challenge. So just to start wrapping this up, I want to say, and I'm probably going to make some bold statements here, but go with me and engage with me in interaction. So ask me questions, argue with me. I would very much like to have your comments. I would argue that we are biased. We are all biased. Any data set can be biased, any model can be biased, and no data is a perfect representation of the world. This is often a common misconception. This is an assumption we go with when we are training machine learning models, that we're using this data, which we believe to represent some underlying phenomena or the world, but it's not never going to be perfect. And there are always some trade-offs made. I would highly recommend this book. If you're not convinced that we are all biased, we all have, with good intentions, good people with good intentions, they still have blind spots, things that we just never question. So that's there, it's inherently there. So again, I think it's very important that we understand and accept that our data are biased and we are biased. Okay? But we want to counteract. So, first thing to do is creating this lens of awareness or education, right? Then we talk about qualifying and quantifying these quantities. Now, in this tutorial, we talked about mostly quantifying them, but it's still important to qualify them. Because as computer scientists, it's very easy for us to think about everything as quantity, and we ask, how do we measure this? How do we increase this? How do we decrease this? Right? So that immediately gets us biased in terms of how do we solve this. But I think there is still an important discussion thread that should continue in terms of qualifying this, right? So, and that needs to continue as well. This is also not one size that fits all. This is personal. So we can't just say, hey, let's just agree, what's good as fair, what's fair, and then just go ahead and implement for everybody. No, this is personal. People are individuals, and they have their own tolerance to what we may consider as fair, what we may consider as right or wrong. And so we have to acknowledge that too. We're not going to be able to just fix all of this by having a set of new algorithms. So, sure, we still need to develop new algorithms. We need to do things to counteract this as much as we can, but that's not going to be ultimately, for solving everything. So there are still things we need to engage in, and for that, I strongly recommend all of us to engage with other disciplines. So not just think about this, oh, this is a machine learning problem. No, this is not a single disciplinary problem. This is a multidisciplinary problem. And so to really make progress, we need to engage with other disciplines. So with that in mind, I hope you've taken away some important things from this. A lot of the material maybe you've already seen some other places, but this is an evolving field. There's always new things coming up. And the fact that you are here, the fact that you watched through this means you're interested. And I encourage you to continue. I'm very happy. I'm very glad that you are paying attention, you are interested in this, at least you're curious about this. We need a lot of help. These are some big and important problems, and we need people not just from computer science and information science, but all kinds of fields to come together. This is a shameless self promotion plug. Here's a link to my lab's, FATE group, the Fairness, Accountability, Transparency, and Ethics. And we are doing some of these. We are trying to address some of these problems, but there's no way we can do all of it. And so we're trying to make collaborations continue, talking to people in not just in computer science and information science, but also outside. So please get connected, talk to us, talk to each other, and that's a way we are going to make some changes. So thank you so much, and good luck.